Hey guys, what's up? How are you all? Welcome to Vedantu's JEE channel, everyone. Well, especially for students who are moving from 10th standard to 11th standard. This is a special series that you guys have been attending for a while now. And yes, we call it JEEt Lo 2022. And today's topic is continuation in the chapter of motion in 1D, or you can also call it kinematics. Yep, the chapter that we are going to talk about today is uniformly accelerated motion. Okay, so story is actually not new. You are aware about it. So no, you all have started studying this part of mechanics, I would say, in ninth standard. For the first time, equations of motion got introduced over there. Okay, so I welcome you all once again on the channel, and I hope you are able to hear me, you are able to see me properly. Hmm? So guys, for those of you who are on the channel for the first time, let me introduce myself. This is me, your Suri Sir, yep, also known as Mogambo. Why am I called Mogambo, guys? Is because when you will crack the examination of JEE in the year of 2022, yes, that's the year when you will appear for this examination. So Mogambo khush hoga. Okay, guys. And also a very important information that I want to share with people who are not aware about it. Those are obviously starting off with the daily schedule that we follow over here. So guys, let me first introduce your teachers to you. This is Love Sir. He is your chemistry teacher. Hmm? This is Arvind Sir. He teaches you mathematics. And yes, this is me, your Suri Sir, also known as Mogambo. And I'm going to teach you physics on this channel. So guys, what is important other than this is to know the timing. You should know that every day at 7 p.m. we meet for theory discussion of PCM. As you can see, today we are discussing theory for physics at 7 p.m. and 8 p.m. on Tuesday, Friday, and Saturday. You come for MCQs discussion with us. Okay. So what I want you people to keep in mind, मैं चाहता हूँ आप लोग ये टाइम याद रखें. The timing is 7 p.m. every day that you have to be on the channel over here. Okay, so not a very difficult thing to remember. Okay, I'm sure most of you have already by hearted the timetable by now. Hmm? Okay, apart from that, if you are not aware, at Vedantu's platform itself, we have a specific batch for 2022 aspiring students running on Vedantu's platform whose enrollment is free of cost. Yes, all you have to do is follow this link which is available in the description of this video, and you can come and enroll for this batch where we are giving you 4,000 plus hours of live teaching. 40 plus master teachers from top IITs are there to coach you for your JEE preparation, and you will get obviously ample amount of testing, instantaneous doubt solving, replays and recordings for the classes that you miss, rank booster quizzes, and previous paper analysis is done over there. Okay, so a lot of things just you have to do is follow this link, come and enroll for this course. Okay, guys. If you have any doubts, anything that you want to understand with respect to this batch, you can come on the comment section of this video and do tell me your doubts regarding this batch. I will get back to you, or somebody from our team will get back to you for sure. Okay, guys. Cool. Let's move on. So the last thing, if you are new on the channel, do subscribe and press the bell icon right away, because you don't want to miss out on anything that is happening on this channel. You want to be the first one who's aware about everything which is coming and happening on this channel. Okay, guys. By the way, on this Sunday, me and Arvind Sir are coming with an epic battle, which is IIT Roorkee versus IIT Bombay. As you know that Arvind Sutar sir is an IIT Roorkee pass out, and I am an IIT Bombay alumni. So guys, on this Sunday we are coming with an exciting session where we are going to have, you can say, a kind of roast session about IIT B and IIT R life. So do not miss out on that. If you want to know the timing, stay tuned to the channel. as I said, subscribe as well as press the bell icon, and it's going to be an epic event on this Sunday, so stay tuned. So guys, I hope you all are ready, and today, as I said, we are going to talk about uniformly accelerated motion. So already in the previous session, we started talking about what exactly is the basic understanding of motion is. Yeah, motion is when anything is moving and it is changing its position. So we'll call that body to be under motion. So previously we talked about the uniform motion, where the object was covering equal displacement in equal intervals of time. But when we talk about uniformly accelerated motion, the situation is going to be a little different. Okay, as you can see, acceleration has come into picture. So what do we call as the acceleration? Let's first understand that. Then I'll tell you what exactly is uniformly accelerated motion. So guys, very simple understanding of the quantity acceleration. It's basically the time rate of change of velocity of the object. I talked about it very much in brief in the previous session of uniform motion as well, but I'm sure you guys are aware about the quantity acceleration. Please try to keep the understanding of velocity and acceleration clear. Acceleration is dependent on velocity's change. If your velocity is changing, that means when a body is moving and its velocity is changing, then only acceleration comes into picture. Otherwise, no. A body can have velocity and can have zero acceleration also. Like for a body which is moving with uniform velocity, constant velocity, the acceleration is zero. Okay, guys. So please remember, it's nothing but the time rate of change of velocity. Okay, and that is why it is also a vector quantity and its direction is same as that of change in velocity itself. Units, SI unit you can see is nothing but meter per second square, and the dimensions accordingly are L1 t minus 2. Okay guys, so with the help of this example also, this diagram, you can see that this body, if it has say some velocity 10 meter per second, after some time say its velocity becomes 10 meters per 20 meters per second, and say this is happening in a time span of 2 seconds. If this is happening in the time span of 2 seconds, then the acceleration can be calculated as v2 minus v1 upon t2 minus t1. The change in velocity is 10, the time in which this is happening is 2, so we can say that the acceleration is 5 meters per second square. So point that I want you people to keep in mind is that acceleration is coming into picture when there is a change in the velocity. Okay, now we'll speak about uniformly accelerated motion. So as the name suggests, uniformly accelerated motion or uniform acceleration. Uniform means constant, acceleration motion. That means what? When the body has constant value of acceleration when it is moving is what we understand as uniformly accelerated motion. By that I do not mean that the body is going to move with a constant velocity, because constant velocity motion was uniform motion. Here the body is going to move with changing velocity, but what is going to be constant is the amount of change of velocity. Okay, so the definition says if a body is moving in such a way that the amount of change in its velocity in equal intervals of time remains constant, or you can say if the body's velocity changes by equal amount in equal intervals of time, we say that the body is performing uniformly accelerated motion. Okay, understood? No, it's okay. Let's have a look at this diagram here. So guys, I am talking about a time gap of 1 second each for a car which is moving on a flat surface. So if the body has a constant acceleration of 1 meter per second square, then let's have a look at its velocity. So initially the car had zero velocity. After 1 second, the velocity became 1 meter per second. After one more second, it becomes 2 meter per second. After one more second, it becomes 3 meter per second. And after one more second, it becomes 4 meter per second. So what do you think will happen after one more second? The velocity will become 5 meter per second. Are you getting the whole feel of acceleration and the constant value of it? Yes, guys. The value of acceleration is basically by which the velocity is going to change in every successive second. That means if a body say has an acceleration of 5 meter per second square, then the body's velocity, if it starts from 0, will become 5 meter per second after 1 second, then will become 10 meter per second, then will become 15, 20, 25, and it will keep on happening till the time acceleration changes. Okay, as long as the acceleration remains constant, the body will have its change in velocity constant. Okay, And by acceleration, I don't mean that body's velocity can only increase, it can also decrease. Okay, that will be called uniformly retarded motion. Okay, guys, cool. So if you ever have to calculate the value of acceleration, I already told you the formula, but let's keep the basic understanding of average and instantaneous acceleration in mind. Whenever you have a measurable amount of change in time given to you, that means you're talking about delta t, and measurable amount of change in velocity is under consideration, then you will say the acceleration that you are calculating is average acceleration. But if you're talking about a very small change in time dt, then the change in velocity will also be relatively very small. So the acceleration that you will be calculating will be instantaneous acceleration. Okay, cool, very nice. Now guys, it's time to further get into the depth of this uniformly accelerated motion and talk about the equations of motion. So guys, these are the three equations of motion that you saw in 9th standard as well. And I'm not getting into the derivation of it as of now. Reason being, the derivations are neither important from your board examination perspective later on, nor they are important from your JEE or NEET perspective as well. So please, let's keep the equations in mind. Equations are V equal to U plus AT, S is equal to UT plus half AT square, and V square equal to U square plus 2AS. This is what you will use when you have time value given and you are interested in finding the velocity of the object. This is what will you use when the time is given, the time instant is given, and you are asked to calculate the value of displacement. Okay, and this is what you will use when velocity and displacements are the thing that you are interested in finding with respect to each other. So either V will be given, S is to be found, or S will be given, V will be found. Basically, time factor will not be given. That is when third equation of motion will come into picture. Okay. Now, what is important to keep in mind with respect to any equations of motion anywhere that you study in mechanics is that all these equations of motion are written for vectors. Okay. These equations of motion are written only for vectors. They are not written for scalar quantities. That means what? This is not distance. This is displacement, which is equal to ut plus half at square. And distance and displacement will remain equal as long as the body is moving along straight line without turning back. Okay. Hope you are able to recall these equations of motion. If not, no problem. We are going to solve a lot of questions today itself to get our understanding clear, as well as more importantly the application part clear. Okay, cool. Okay, now something that you did not study in 9th standard is what I want your focus here upon. So guys, we studied calculus, and in that we studied differentiation as well as integration. I hope you guys are still aware that when we calculate the value of differentiation, or we differentiate dy by dx, this basically imply the slope of the tangent on a graph, right? Which may be a new quantity in itself. Similarly, when we integrate and we find out, say, y dx, this is basically what we say implies to find out the value of area bounded by the graph between y and x, and may again result in a new quantity itself. Now the time has come to actually start applying the calculus part that we learned. Okay, so guys, if we are ever dealing with the displacement versus time graph in uniformly accelerated motion, first of all, as you see that the equation is s is equal to ut plus half at square, which says that displacement is proportional to t square. So the graph is basically a parabola. Okay, so the displacement versus time graph in uniformly accelerated motion is a parabolic graph. And at any point on the graph, if I go and I draw a tangent on that point, guys, then the slope of that tangent, if you try to find out, that means tan theta, if you try to find out, you will basically be calculating ds by dt, change in y upon change in x. On y axis you have displacement, on x axis you have time. So what you are actually calculating is change in displacement upon change in time, which is nothing but instantaneous velocity at that particular time instant, whichever time instant you went and you were trying to find out the slope of the tangent on. Okay, so point to be kept in mind whenever we are dealing with the displacement versus time graph. If I go on the graph, at any point if I draw a tangent, the slope of that tangent is going to give me the instantaneous velocity. Okay, and the nature of the graph is a parabola for the uniformly accelerated motion. Okay, please keep that in mind. We are going to use this information a lot in the coming time. Similarly, the most important graph of any kinematics case is the velocity versus time graph. Now, why velocity versus time graph is the most important one? First of all, if you look at the graph, velocity and time, they are related as v equal to u plus at, which is basically a straight line graph. So you can see that this is the initial velocity, this is going to become final velocity after traveling for a time t. Okay, so why this graph is important, guys, is first of all, if you try to find out the slope of this graph, if you try to find out the value of tan theta, that tan theta is basically going to be uh, the opposite side, which is v minus u divided by the adjacent value, which is basically the change in time. And change in velocity upon change in time is nothing but your acceleration. So what I want to tell you here is that the slope of velocity time graph is going to give you the acceleration value. Okay, and if you try to find out the area bounded by this graph, if you try to find out the area, then the area will basically be displacement. Why it will be displacement? Is because what you'll be finding is integral of v dt. Okay, because on y-axis you have velocity and on x-axis you have time. So this is why you will be calculating displacement as the area bounded by velocity time graph. And here it looks like a regular shape, so that's why velocity time graph is going to become a very, very, very important graph for us, because it's going to help us find out both the informations, acceleration as well as displacement. Okay, I will show you a few questions where we are going to apply or rather use the graph between velocity and time to solve a question. Okay. Now this one, a very simple one, because it is uniformly accelerated motion, so obviously the acceleration will be constant. So the graph that you are getting is basically a straight line parallel to x-axis, and on this, if you basically try to find out the area bounded by the graph, then the area is going to be integral of a dt, which is going to give you the change in velocity. Okay, not a very useful graph in general, but still keeping in mind the fact that the area bounded by the area acceleration time graph is going to give you the change in velocity. Okay, cool. Okay, now the equation which you do not know from 9th standard and we want to derive it over here is something that we call as equation for the displacement traveled in the nth second. Let's first try to understand what exactly we mean by nth second. So guys, when the object, any object which is moving with constant acceleration, say the time gap in which it is traveling is t equal to 0, then 1, then 2, then 3, then 4. So when the body is traveling between 0 to 1 second, we say that it's basically the first second of the motion. Between t equal to 1 and 2 is called as the second of the motion. Between t equal to 3, t equal to 2 and 3, it's called as the the third second of the motion. Okay, and between 3 and 4, it's called as the fourth second, and successively, if you keep on going forward, then between n minus 1 and n second, this is basically what we understand as the nth second. What I'm trying to tell you, that if you ever see the situation where you are being asked to calculate the displacement, say traveled in fourth second, then that's basically the displacement that is covered by the body between t equal to 4 second minus t equal to 3 second. Means when the body is traveling, if I cover and find out the entire value of displacement traveled by the body when it travels for 4 second, not fourth second but 4 second. Okay, so in that time we'll calculate the displacement, and after that I'll try to calculate the value of the displacement traveled in the 3 seconds. So the total displacement traveled in 4 seconds minus displacement traveled in 3 seconds, that gap of displacement is what we understand as the displacement covered in fourth second. Let me give you an example first, guys. So if I say that initial velocity of a body is 0 and its acceleration for our purpose is say 2 meter per second square. So the equation of displacement S is equal to ut plus half at square. Okay guys. So we have u as 0, acceleration as 2, and t is something which is going to change. So the equation, very simply, the simplest of the equation that I'm getting is SCC is equal to t square. So now I want to say calculate the displacement traveled in fourth second. So I'll do one thing. First I'll calculate the total displacement covered by the body in 4 seconds. So I'll just put the value of 4 here. So what I'm going to get is 16 meters. So if the body covers a total time of 4 seconds, then the total displacement that the body will cover is 16 meters. Okay, starting from t equal to 0, if I let the body travel for 4 seconds, from its initial position, the body is now at a distance or displacement of 16 meters. And if I now calculate where was the body after 3 seconds, then what I'm getting over here is 9 meters. So what do you see here, guys? What do you see here? In fact, if I just calculate S2 also for our understanding, which is 4 meter, and S1, so that is 1 meter. So on the distance line over here, if this is the origin, then at t equal to 1 second, the body is at 1 meter, then the body is at 4 meter, then the body is at 9 meter, and then finally at 16 meter. So this is t equal to 0, t equal to 1, t equal to 2, t equal to 3, and t equal to 4. So what you see here, guys, is the amount of displacement that the body is covering in this 1 second is 4 meter minus 1 meter, that is 3 meter. Similarly, this is the displacement traveled in this 1 second, that is third second. The displacement covered is basically 9 minus 4, that is 5 meter, and the displacement that is covered in the fourth second, which is the time gap between t equal to 4 and t equal to 3, you can see 16 minus 9 is equal to 7 meters. And similarly for the first one was the 1 meter. I hope the idea is clear so far. I'm going to generalize it by finding a formula for it as well. And right now I have a very important information for you to store. So whenever we are talking about an equal time interval gap in uniformly accelerated motion, the displacement covered in the successive seconds is going to be in the ratio 1 is to 3 is to 5 is to 7 is to 9 is to 11. You can see that after every 1 second, the body's successive displacement that it is covering is going in the ratio 1 is to 3 is to 5 is to 7. Next would be further 9 more add if you will do. In 16, if you'll add 9, it will be basically 25. And if I put t equal to 5 here, I'm going to get 25. Okay. I hope the things are getting clearer to all of you guys here. Okay. Cool. So let's erase this and let's go to find out the formula for it. So we are going to represent it as Sn, and I'm going to find out Sn as Sn minus Sn minus 1. Okay, time for nth second, the amount of displacement traveled in that time minus the displacement traveled till a second before that. So Sn is going to be un plus half a n square, and Sn minus 1 is going to be un minus 1 plus half a n minus 1 the square. So let's open this. This is un minus u plus half a n square minus 2n plus 1, because that is a minus b the whole square. Okay, so if I just take this and open it up as well, so I have un minus u plus half a n square minus a n plus a by 2. That's what we are getting as S n minus 1. So now S n is going to be this. Putting up, I have un plus half a n square, okay, and minus this part, which is un plus u, minus is getting multiplied, so that's why signs are changing. Okay, guys, this is what we are getting. Every sign has got changed in the expression of Sn minus 1, Sn as it is. So you can see un is getting cancelled and half an square is getting cancelled. So I have u plus a by 2. If I take common from here, then I have, from here I will have 2n minus 1. You can multiply a by 2 inside and you will see that this is what you're going to get. 2 will get cancelled, an will be left and a by 2 will be there. So that's why this is the formula that we were looking for. The formula which says the displacement covered in nth second is u plus a by 2 to n minus 1. Okay, so now by using the same formula, which is u plus a by 2 to n minus 1, if I now put u equal to 0 and a equal to 2, then for n equal to 4, I should get the value of the displacement covered in the previous case which we found, 16 minus 9, it should come out to be 7. So S4 will come out to be 0 plus 2 by 2, and here 2 into 4 is 8 minus 1. You can see it comes out to be 7 meters. Okay guys, so this is going to be helpful when we are going to talk about displacement covered in a particular 1 second time. Okay, please keep this expression handy, try to remember it if you can. Okay, cool. Let's have a look at the examples based upon the same. So a body starting from rest has an acceleration of 20 meter per second square. We have to calculate the displacement covered in fifth second. Very nice. So we just found out the expression, the formula as well, which is basically Sn u plus a by 2 2n minus 1, and I'm going to put n equal to 5, and because it is starting from rest, so u is 0, acceleration is 20 divided by 2, and 2 5s are 10 minus 1, so this is what I'm getting, 10 into 9, that is 90 meter. Okay, that's our answer, 90 meter. That much displacement the body will cover in the fifth second, that is time between t equal to 4 and t equal to 5. Okay, cool. Let's try this one. Driver of a car applies brake when the car is moving at a speed of 20 meters per second. So at a distance of 50 meter from the wall, the brakes were applied. So brakes are producing a constant retardation of 5 meter per second square. We have to find the distance of the car from the wall at t equal to 3 seconds. So we don't know even after 3 seconds the car has already hit the wall or not. So we don't know that. We'll still try to figure it out. So basically your car is somewhere over here. Okay. Yeah, you can see a Tom and Jerry level of diagram here. I'm very good at drawing cartoons. You can see that. So already the car is at a gap of 50 meter and it is moving with an initial velocity of 20 meter per second, and after 3 seconds say the body is going to cover some x distance and is going to reach here. I don't know what is going to be this value of x. It could be more than it could be actually equal to 50, or it could be actually less than 50 also. So what question is asking is to find out the distance of the car from the wall. That means we are actually interested in finding this value of say x dash, which is 50 minus x, by the way. So simple, all we have to do is find out the value of the displacement covered by the car, and by the time the car will reach here, obviously its final velocity has to become 0 after no, we are not sure whether the velocity will become 0 or not. That's not what the question is asking. Pardon me. Question is only asking us to find out the displacement covered in 3 seconds and where exactly the car is with respect to the wall. So guys, simple, S is equal to ut plus half at square is what we should go for. Yeah. So in this, what is going to happen? The displacement that the car is covering is x, initial velocity is 20. After 3 seconds, the question is asking us to find out that value, and acceleration is minus 5, or I should say it is retardation. That's why we are using it as minus 5, and time is 3 seconds. So ut minus half at square. So this is 60 minus 9 5s are 45 by 2, which is 120 minus 45 by 2, that is 75 by 2. So x basically comes out to be 37.5 meters. So this much amount of displacement your car has covered. But how far is it right now? So it's definitely not hit the wall. So how far is it from the wall? X dash is going to be 50 minus x, that is 15 minus 37.5. So your car is basically 12.5 meter away from the wall. It is still at the distance of 12.5 meter. It has still not hit the wall at t equal to 3 seconds. Okay, awesome. Now this one guys, this is a JEE 2004 question. This says that an automobile traveling with a speed of 60 km per hour can brake to stop within a distance of 20 meters. So a car is already moving or automobile is already moving with a speed of 60 km per hour. When you apply the brake, the car covers a distance of 20 meters and final velocity becomes 0. Now the question says if the car is now going with a speed that is double, that is 120 km per hour, if the rate of retardation is considered to be same because nothing has been said, then what is going to be the distance that is covered by the car before its final velocity now becomes 0 when it comes to rest now. Okay, so here we will consider obviously that there is no understanding of time here. Obviously the time is going to be different for two cases because the speeds initially are different, so they will take different amount of time to stop. You have to actually visualize it. Think of yourself as the person who's driving a vehicle. Brakes are applied looking at a red signal. So if you are moving very fast, you will require more time to stop, more distance to stop. But if you are traveling with a very less speed, if you apply the brake, your car still or your vehicle still has the same brake capacity. This time it will stop relatively earlier as well as by covering lesser distance. So I say that if I use no information of time is given, so in fact I'll go by v square equal to u square plus 2as. Okay, so final velocity is going to become 0, initial velocity is u, and acceleration is not acceleration but retardation, so that's why minus sign is being used here. So s basically comes out to be u square by 2a, and if in both the cases the rate of retardation is same, we can say that u is proportional to, sorry, s is proportional to u square. That's what is to be used in this question. Okay, so I can say that s dash by s is equal to 2u by u the square, because initially velocity is 60, then it becomes 120, so double the velocity. So this ratio basically comes out to be 4. So in the second case, the displacement covered will be 4 times the original displacement, and that basically comes out to be 4 into 20, which is basically 80 meters. So your car this time will require to cover, or vehicle will require to cover a displacement that is 80 meter or 4 times the previous case in order to stop by the same rate of retardation. Okay guys, cool. Okay, now the question where I will explain you how we can apply how we can solve the question by graph. But let's first read the question and see if we solve this by equation what happens. An object is moving with an initial velocity of 10 meter per second and a constant acceleration of minus 2 meters per second square. Now when I say minus 2 meter per second square, it could be acceleration in negative direction or it could be retardation. So this could be retardation also, or it could be acceleration in negative direction because nothing has been specified. So it could be both. So we have to find out the total distance traveled by the object in the 6 seconds. Okay. So if you go by s is equal to ut plus half at square, and you put the value of u as 10, time as 6, plus half, this is minus 2, and 6 square. So you have 60, this got cancelled, minus 1 this is, so this is minus 36. Your answer comes out to be 24 meters. Okay, and let me tell you, you got the answer, but then the answer is not right. Why, sir? I applied the equation correctly, the value of a used correctly. You must be thinking, no, acceleration has to be used plus 2 over here. But that is also not the case. You have correctly calculated the value. But what you have calculated, my dear friends, is displacement. I hope you guys remember what did I tell you all, that whenever we are dealing with this chapter in kinematics, every time when we deal with any equation over here, all those equations are valid for vector quantities only. Okay, so what right now we are dealing with in the situation, guys, is, let me take you back over there. What we are dealing here is basically distance, which is basically a scalar quantity. So that's why what you calculated is not incorrect in terms of calculating displacement, but incorrect with respect to the question that we are given over here. So first thing that I want to tell you all, that whenever you are dealing with a question which asks you to calculate distance in kinematics, you have to be extra careful. And I would recommend, whenever you are being asked to calculate the value of distance, try to always go by drawing the graph only. When you will see the graph, you will understand what is happening here. So you can see that because initial velocity, this is velocity and time graph I'm drawing. So initial velocity is given as 10, but it has acceleration -2. And we know that velocity time graph will have its slope as acceleration and slope is negative. So this is how the graph is going to go. So if you look at this 10 meter per second, after how much time do you think the velocity will become 0? So if it is 10, after 1 second it is going to become 8, after one more second it will become 6, then 4, then 2, then 0. So this is t equal to 1 second, 2 second, 3 second, 4 second, and after 5 second the body is going to attain its 0 velocity. But after how much time you are being asked to calculate distance? This is where the situation is getting trickier, that after this time the body still has the same value of a, that is -2 meter per second square, but now the body has entered into the negative zone, which means the body's velocity has now become negative. So what is happening? Body was going in a particular direction, but retarding. It stopped because this is where the body's velocity was positive, positive, positive. So body was going in this direction but was retarding, and after that the body stopped here at t equal to 5 second, velocity became 0, and after that the body again started to come back. So body went from A to B and from B to C. So this is your A, this is your B, and this point is basically your C. So you can see that the displacement is 24 meters, but the distance is going to be more than displacement here. So if you want to find out the answer, let's find out the value of displacement S1 and S2 by calculating the area bounded by the graph. And we'll not take this negative displacement. Let's first find out, this is positive displacement, this is negative displacement. S1 is going to be half into 10 into this time, that is 5. This comes out to be 25 meter, obviously positive. And S2 comes out to be half into velocity -2 into 1 second, because this gap is 1 second. This is t equal to 6. So what you get is -1 meter. So if you just add it right away, S1 plus S2, what you will get is 24 meters, which is basically displacement. But if you will take S1 and modulus of S2, what you are going to get is 26 meter, which is your answer, because that is basically the distance covered by the body in 6 seconds. Okay guys, I hope the whole idea is clear now. When to use graph, how to use graph. In the single question I've given you the idea of everything here. Okay, whenever you are being asked question to find out the value of distance, be extra careful, draw the velocity time graph. You will never make a mistake in that. Okay, cool. Okay, now let's move on and speak about a special case of uniformly accelerated motion called as motion under gravity, also understood sometimes as free fall. So in this, what will be studied is a body which is thrown vertically upward or a body which is moving vertically downward, both the cases. Okay, so here everything is basically same. It is motion with uniform acceleration, value also known to you as g, right? 10 meter per second square, or precisely 9.8 meter per second square. But what I actually want to tell you here is that when the body is going to go up, it is going to travel in positive direction, but it is going to retard. When you throw an object upward, what happens to its speed? It decreases. So when the body is going towards positive direction, it's basically going to retard. Okay, and when the body is going to travel downward, we'll consider it to be traveling in negative direction. So when a body is dropped, when it is moving downward, the body is going to accelerate. So what is important for you to understand, that when the body is going upward, you will use the value of acceleration instead of calling it acceleration but retardation. So you will put the value as -g. Why? Because the body is going in the positive direction, that is upward, but the body's velocity is going to decrease in terms of magnitude. But when the body is coming down, its velocity is going to increase, but it's going to increase in the negative direction. That's why you'll use the value of acceleration as -g. So please understand, this thing is retardation and this thing is negative acceleration. Okay, what is in nutshell that I want you people to keep in mind, is that always and always the value of A in the case of motion under gravity will be put as minus G. So your A is basically minus G with value of G most of the time put as 10 meter per second square. Okay, and equations will become V equal to U minus GT, H, or you can say Y equal to UT minus half GT square, and V square equal to U square minus 2 into G into Y. Y is basically to represent the Y direction motion over here. So you can see that equations of motion are not changing, only the value of A is something that now you will always be aware about. The question will not give you the value of G. If it does, then it's good. If it doesn't, then you have to always assume the value either 10 or 9.8 meter per second square depending upon the values of U and displacement. If the velocity is given as 9.8 meter per second, 19.6 meter per second, it's a hint that the value of G has to be used as 9.8 meter per second square. But if the value of velocities are 10, 20, 30, 40, means integer values, then the acceleration has to be used as 10 meter per second square. Okay guys, cool. So let me again clarify this with the help of examples here. Let's see the very first question. This says that a stone is released with zero velocity. That means it has been dropped from the top of a tower and it reaches the ground in 4 seconds. So we have to find out the height of the tower. So guys, it's quite understandable that when you are dropping something from the top of a tower like this, so when the body is going to start moving, its velocity say 0, and when it is traveling downward over here, the direction of motion is negative and the displacement that is covered by the body is basically minus h. Why minus h? Because that's basically the height of the tower, right? So while moving from point A to point B, body starts moving with zero velocity, moves in negative direction, that's why negative displacement minus h, and finally when it is going to hit the ground, it is hitting in 4 seconds. So we have displacement to be found, we have initial velocity known, G value is known. What will you use G as? Obviously you will use that 10 meter per second square and acceleration as minus G. Okay, so let's go. The equation is y equal to ut minus half gt square. So y is minus h, initial velocity is 0, and minus half into 10 into 4 square. So minus and minus get cancelled. H comes out to be 4 for the 16, 16 into 10, 160, 160 by 2 is 80 meters. As simple as this, guys. Okay? Okay, everyone. Great. Now this one, this says that a body A is projected upward with a velocity of 100 meter per second. The second body B is projected upward with the same initial velocity, that is 100 meter per second, but after 4 seconds, and both the bodies will meet after how much time? From obviously the first body, since the time it was thrown, that is the time when we started our stopwatch. So what is happening guys here? A body was thrown from here, it went upward, 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 and just to show our understanding, just to be clear with our understanding, say this body starts coming down, and by the time this body has started coming down, a body which was thrown from the down has also started going up and it meets it somewhere over here. So this is basically the path followed by the second body, the blue one, and this is somewhere they both hit, which simply means they both basically have the same height, same displacement rather I should say. The only difference is body 1, body A, has traveled say for t seconds, then body B has traveled 4 seconds less. That means it has traveled for t minus 4 seconds. Okay guys, so now we'll try to simplify this one. Both of them are covering the same amount of displacement, so we'll say that YA is equal to Y of B. Y of A is basically UT minus half GT square, and Y of B is UT minus 4 minus half GT minus 4 ka square. Okay, So guys, right hand side I'm opening up so that things simplify a bit. I have ut minus 4u minus half g t square minus 8t plus 16. So you can see that ut get cancelled and I have minus half gt square equal to minus 4u minus half gt square plus 4gt minus 8g. That's what I'm getting. And this also gets cancelled. So 0 is equal to minus 4u minus 8g plus 4gt. So let's find out the value of t here. So I have 8gt equal to, sorry, 4gt it is. So 4gt is equal to 8g plus 4u. Okay, that means t will be equal to 4u by 4g plus 8g by 4g, which is nothing but u by g plus 2, as simple as that. So initial velocity with which the body was thrown was 100, g value is 10 plus 2, that simply comes out to be 12 seconds. That means these two bodies are going to collide with each other at t equal to 12 seconds. Okay. By the way, the first body reached the maximum height, and you can find that also by v square equal to u square minus 2g capital H. Capital H is the maximum height, and final velocity has to become 0 at the maximum height. So h will be equal to u square by 2g. So initial velocity was 100, and that is 2 into 10. So 5 meter is basically their maximum height, and this was attained after how much time is something that you can also find out by v equal to u plus 80. My mistake, actually I should have directly gone with v equal to u plus 80. From there I can find out the time value. Final velocity becomes 0 and t will be equal to u by g, that is 100 by 10. 100 by 10 is giving me 10 seconds. So after 10 seconds only the first body reached the maximum height. For next 2 seconds it started coming down. Okay, so this was achieved at t equal to 10 seconds. This happened at t equal to 12 seconds. So 4 seconds less is basically what this body traveled, and that is 8 seconds. So first body has traveled for 12 seconds, second body travels for 8 seconds only. Okay guys, I hope you understood it. Cool. Now for you guys to try at home, the question for the day. So we have a ball which is released from the top of a tower of height h meter, and it takes capital T time to reach the ground. Okay, and we have to find out the position of the ball at t by 3 seconds. Okay, so at t by 3 seconds, what exactly is the position of the ball that you have to find out? Your options are here for all of you to see. Where do I want you people to tell me the answer? I want you people to tell me your answer in the comment section. Okay, everyone, tell me the answer in the comment section and I will verify which of these is correct. It's a tricky one, so be careful when you are attempting. And obviously, the equation that you will use is ut plus half at square to find this out. And when the ball is being released, obviously the initial velocity is 0. Acceleration value, please use it as minus g. Okay, cool. Okay guys, so this is the uniformly accelerated motion for today. If you want to cover up topics before this lecture, whatever I have taught before this lecture, if you want to know how can you cover it up if you have missed any of the classes, then all you have to do is go on the playlist of the channel and look for 2022. Also the entire repository of it is available in the description as well of this video, so you can find it out from there. And do cover up all the chapters, all the lectures that has been done before this one, so that you are in sync with the class. Okay, also guys, if you want to be informed about the assignments and solutions, more study materials and daily updates about the Vedantu JEE channel, then all you have to do is come to our Telegram channel, which is available to be joined. The link, by the way, is available in the description of the video. Follow that link and I'll see you on the Telegram channel as well. So guys, this brings us to the end of the session itself. If you enjoyed this session, hit that like button, share with your friends, tell them about the lectures going on the JEE channel itself, and more importantly, if you have not, then subscribe to the channel right away. Press this bell icon and be notified about all the sessions, motivational, academic, any informative session which is happening on this channel. Be the first one to know. Okay. So with a promise that even during this difficult time of pandemic, the learning won't stop. I'll see you again very soon, and we'll be continuing the chapter of motion in 1D. We'll obviously meet again in the next week. Till then, keep studying, keep enjoying physics, and don't forget to watch me and Arvid sir on this Sunday. To know the timing, come on the Telegram group, and also you can subscribe as well as press the bell icon. Cool. Chalo then. Bye bye, guys. Take care. Stay safe. Bye bye.